All right, it's 2 o'clock. It's time to start. Can you all hear me all right? Give me some thumbs up on the chat if you can. All right, awesome. That's great. Hello, everyone. Welcome to NodeSchool San Francisco Online Edition. This is our focus session for April 2020, and I don't want to overhype it, but I'm pretty sure this is going to be our best focus session of April 2020 ever. It's also only one, but don't let that fact distract you. It's going to be great. So what you're seeing right now is roughly our agenda for today. 2 p.m. we're doing intros, which is what happens now, like super meta, right? In a few minutes, we're going to kick off our session. And right after that, we'll have a few minutes for Q&A with our guest speaker, all right? All right, so quick show of hands via Zoom or like in your homes. Who's coming to NodeSchool for the very first time? All right, I'm pretty sure there's a lot of you, so thank you for joining us today and welcome. Most people will never return, so we really hope that you have a good time today. If this is your first time joining you, let me fill you in on what exactly is NodeSchool. So the official definition is that NodeSchool is an open source project run by volunteers with one goal in mind, to help you learn Node. And we do that by creating programming content and by hosting community learning events such as this one and our usual in-person events. Sadly, due to the current situation we're living right now, we're not running in-person events for the foreseeable future, but we're trying our best to find ways so we can stay connected, share some things with you, and have a good time. We really miss you all, and we hope that you're staying safe, and we hope to see you all soon, all right? So the two faces that you see on that slide are your organizers of the chapter, the wonderful Thomas, who's, I think, is on the Zoom meeting with the forest background. Hey, Thomas. Hey. And me, hey, and me, Fernando. Even though we're not at a venue, we still have a co-conduct for this event. So the real short version is that we are creating a harassment-free community for everyone, and we want all people to feel welcome and a part of this. So we ask you to please, please, please be kind to each other, especially in the chat if you're going to ask any questions or if you're going to say anything. And if you want to read the full version of our code of conduct, you can go to our website, nodeschool.io/San Francisco. And we have some housekeeping rules, even though we're not physically at a venue. But if you're in Zoom, we ask you to please mute yourself when you're in here and try not to interrupt the presentation. If you're in Zoom or YouTube, drop your questions in the chat. We're going to be monitoring both places, and we're going to be saving questions for the end of the presentation. But also, if we can answer anything during this time, we'll do so as well. Most importantly, wash your hands. And this is a question that it's on everybody's mind, like snack and drinks, right? The good news is that you can grab whatever's in your kitchen right now and eat it during the presentation. It's gonna be great. So whatever you have, go nuts. And picture, well, like screenshots, right? So take as many as you want. They're free. Tell your friends and share in social media. If you're sharing though, keep in mind to tag us on Twitter @NodeSchoolSF and use any of the hashtags, #NodeSchool, #SF, or if you're feeling like really, really well today, do #NodeSchoolSF. If you tweet and you tag us, we will retweet you and make you internet famous to our 72 followers. So it's a great opportunity. Take advantage of that. It's gonna be great. And if you want to get in touch with us or need to give us a shout, or if you want to give a session or have any feedback, you can shoot us an email at nodeschoolsf@gmail.com or slide into our Twitter DMs. They are, in fact, very much open. And even though these are strange times, we're still not the only game in town, which is really good news. There's more Node and more JavaScript around. So if you want to check something else, you can watch SF Node live on May 14th and find more info on their meetup page. Or you can go to Waffle.js, also online on May 6th. And you can find more information on their website, wafflejs.com. And all right, the moment that you're all here for probably. Today's focus session, our guest speaker today is Sam Saccone. He's an engineer working at Google, and he's also a former mentor of this chapter here at NodeSchool San Francisco. We're really happy and grateful to have you here with us today, Sam, sharing some knowledge with our community, and we're really looking forward to hear all about your sessions. So now I'm gonna stop sharing my screen and I'm gonna kick it off to Sam so you can take it away.
Hello, everyone. I may be over-prepared. We'll go off. Happy to be here. Thanks everyone for tuning in. Let me go ahead and share my screen. Right. And thanks again to Fernando and Thomas for setting this up, reaching out. and helping to make this event happen today. So I have chat open from YouTube, so if you have any comments, feel free to throw them in there. You can interrupt me at any time, very fluid. So hello. So I'm Sam. I have a GitHub profile and a Twitch profile. Feel free to follow me there, where I will tweet and push code randomly, and you can follow along. So today, I wanted to run through a few different performance case studies, or micro case studies as I call them. The first is how we can understand our network critical path. The second is finding the performance bottleneck inside of your application. Then at the end, I'll provide some additional resources for you to learn more, and then we can engage in some informal Q&A. So let me kind of go over these case studies before we dive in too deep. So I pulled two applications that I've worked on over the last few years, and I've investigated each one and found some performance wins that we could get and implement the fixes. And so we'll be able to compare before and after and see exactly the impact of doing this kind of work. I've found that on most websites, there's significant opportunity in understanding your network critical path. So that is what network requests have to happen in order for that page to render. So a lot of applications will make many requests before they paint anything to the screen. So as a user with a phone or on a poor network, it can be quite frustrating as you're waiting for many requests to happen. So understanding the network overhead is really important because it will tell you sort of where to optimize and where to invest to make your application load faster. The second case study is all about performance overhead of JavaScript in your web application. So a lot of times when we're writing code, we may not be thinking about the performance bottleneck or performance overhead. Sure, if we're writing a nested for loop, we might say, this is O of n or O of n squared, not so great. Let's unroll that loop and put a cache somewhere so it's faster. But oftentimes in our web applications, the performance bottleneck actually is in these interactions or these micro interactions, whether it's pressing a button and a ripple showing behind a button, or it's dragging and dropping something on the screen. These sort of performance bottlenecks can get in the way of your user and can cause a lot of friction. My favorite one that I always reference is the hamburger menu on every single web application. I'm sure we've all had the experience of pressing the expand on the hamburger menu and then nothing really happens for a second or two. And then eventually at 1 FPS, it shoots out. And you know the developer didn't actually want it to work that way. There's probably an animation there, but it's just so expensive and there's so much other stuff on the page that the sort of interaction is not great. So we're going to dive into looking into this interaction performance bottleneck and make some optimization fixes. All right, sound good? Everyone's silent, so I assume yes. The first thing I want to talk about is our network critical path. So I think 2 years ago, like everyone, I made a Hacker News PWA clone, because why not? So I went back through my archives and loaded these up. So amazingly, the API still works. So we have Hacker News clone. You can see comments. It's great. I spent a while making sure I used no framework. So I was able to get the page to load quite quick. And also the JavaScript that's required here is only 2 kilobytes, which is, I think, smaller than Preact, just about. But like everything, there's always room for improvement. So let's take a look at the performance characteristics of this page. So for those of you that are not familiar, we're going to be using DevTools. And to access DevTools on the page, we can right-click on the page and we can go into this menu called Inspect. You can also do Control Option or Command Option J or I, which will open DevTools for you automatically. Today, we're going to be spending a lot of time in this tab called Performance. So you may not see performance in all of your tabs. If you don't, you can always click on this expand button, and then there's all these different tabs inside of DevTools. So to profile this, we're specifically curious about the loading time. And I'm not talking about just the server loading. I'm talking about until we actually see content on the page. So if you'll notice when we reload, there's that flicker. And this is what gets me. I see blank and then some information. So this is on I'm on a high-speed internet connection right now, and I still see this delay. So I asked, what is this experience like for network? So to experience that, we can go into the network tab, and then there is a drop-down here. Right now it says online, but we have some additional presets that we can change. We have fast 3G, slow 3G, and then offline, and we can even add custom throttling characteristics. So let's see what this site looks like on slow 3G. So I will change the throttling. I'll clear this. I'll also do an additional trick that I like to do, which is go into the Elements tab, select my body, and then delete. So a lot of times what Chrome tries to do, because it's smart, is it will show the previous page until the new page loads in. And when you're testing the same page over and over, this can be pretty misleading, because you say, oh, the page is fast, it shows something and then it finally loads. But the reality is that you're actually seeing the previous body element. Misleading. So I like to always go into DevTools and then delete the node. I did that just by pressing the delete button on my keyboard. You can also go in, right click on a node and do delete as well. Okay, so now that we're set up, we have network throttling on. We also have screenshots on. I will press the start profiling and reload page. Looks like a little refresh icon. But one additional check that I would recommend. By default, Chrome DevTools does not disable cache. So this is important. There's this checkbox here, and you'll want to have this checked. So what disable cache does is it disables any network cache or browser cache that Chrome does by default. So again, if you're trying to profile your network loading speed, make sure you have this checked. Otherwise, you're going to be getting a cached experience, which is going to be much faster than if you were loading a page cold from the network. All right, so slow 3G, disabled cache, performance, we deleted the body. So let's press the start profiling and reload page button. There's that blank spot, and then it finally pops in. Great. So what exactly is happening here? Why are we seeing this delay? I'm going to expand this area here so we can get a little more detail. Now I had screenshots enabled. So if this is your first time kind of diving into the performance tab, I'm going to break down all these panels so we can understand what all this is, because I know it's quite overwhelming. So at the top here, this is our, I like to call it the butter bar. It shows your main thread activity broken out by JavaScript, paint, compositing, etc. So we can see that we're not really doing much work here. It's pretty much flat. And this flat area tells me that we are network bound, that it's making a bunch of network requests. Here we have a network expandable accordion section, and we can see all the network requests that are happening to load this page. So we are loading this page, and then we start loading some JavaScript. Then it looks like we're loading a few JSON files. And as I hover this, I can actually scrub on this screenshot. And I can see the application kind of loading in. So once our top page loads from the server, we can see pretty quickly we get that header bar, but then we have this long period of nothing. Still nothing. And then at the very end, our content loads in right here. So what is going on for these 5 seconds? Well, we're downloading JavaScript, we're downloading JSON. And then finally, when it has the JSON, the page probably calls render. So I say, okay, we're clearly network bound on 2 requests. We are bound on a JavaScript request, and then we're bound on a JSON request that's happening. Notice down here, this section called main, this is where our JavaScript and our flame chart would normally show. But in this entire area, we have almost no work happening at all. And I can tell because there's nothing here. Again, we're making network requests and we're just stuck waiting. So at this point, I asked myself, all right, what can we do to collapse this graph, to identify our critical path for what is required to paint? And how can we flatten that graph so that we can get it to load a lot faster? Now, for me, I say, okay, well, stories.json, what is actually starting this network request? So to understand where this request is starting from, I can select the node directly in this network section just by clicking on it, and then pull this bottom panel up and look at the summary tab. In the summary tab, we see at the bottom, we have an initiator. Initiator is a way to say who called this request or who made this request. We can then click on the initiator here, which takes us to a minified JavaScript file. Not so helpful. However, DevTools is kind of helpful in that it has a pretty print function in the bottom left of any sources panel. So again, just to make sure everyone followed along, we went from a network request here. We clicked into the node, we clicked in the bottom area, we went to summary, we clicked on initiator, which pulled us into the sources tab. We can then go into the bottom left and press preprint. Preprint will preprint the file. It's still minified, but it looks a little better and it's much easier to understand what's going on. If you're like me, you can't really read minified code that well. Now what I usually do, because you'll notice we're now at the bottom of the file, is I will go back to the performance tab, and then you'll see that our initiator changed from cc.js line 4 to line 74. We can click on line 74, and then here we are. We are at this function T that is making the request to stories.json. Cool, okay, so that all makes sense. Now, I did some poking around, and we don't have to walk through the same exact workflow, but I noticed that whenever I load the page, I'm loading a scope called top stories, an offset of 0, and 30 results. This is static. I know that whenever I load this page, I'm always going to be requesting this, which makes me think, why do I need JavaScript to execute to tell me that I need to fetch this? Because it's always the same. So at that point, I asked myself, well, how am I supposed to make a network request if I don't have JavaScript running? Luckily, the browser and the kind folks in spec land have come up with a way to control this. It's called Linkrel Preload. Linkrel Preload is a link tag that you can push via a HTTP header or put into your DOM, that when the browser sees that tag, it acts like an image tag, so it will load right away. Think of it like an image tag, more or less. The browser scans, says, oh, I need to download this thing. So I'm going to start downloading this thing so that the browser can have it when it needs it, versus having JavaScript run a request. And since JavaScript doesn't have to run, it means that we can start downloading the stories.json all the way over here, instead of having to wait for cc.js to finish downloading, then to run a tiny bit of JavaScript to fetch a known resource. Okay, so that was a lot. So I've gone ahead and made that change. Cool. And I have another page, so we'll take a look. Additionally, for those that are following along, I have a, I put the link to the slides in the YouTube chat. You can also just write it in manually from here if you want to follow along. All of this is open. All right, so here's our new page. Let's take a look. So if we go into our performance tab, let's do our 37 steps again. Network 3G, screenshots on, delete the body element, make sure caching is off, great. Okay, and reload the page. Okay. All right, well, look at this. We now have stories.json executing at the exact same time as cc.js. So this is essentially telling us that by making the fetch earlier, we were able to get the page to load faster. Makes sense. Additionally, you'll notice that when we click on stories.json, we no longer have an initiator. That's because the browser is starting this. We can confirm this where we can go into the network tab, which is another tab in DevTools, and we can see stories.json right here. And we can see that the initiator here is set to other. Before it was set to cc.js. So now the initiator is directly from the browser. I said there was two ways that we could do this. We could push an HTTP header, or we could use a Linkrel Preload tag in the actual DOM. In this case, we pushed it via a header, a link header, and that looks like this. Resize this for us. I think I broke DevTools. There we go. So here is our top response headers. And here are our link preload tags. So we can now see that we're pushing a link HTTP header that is loading stories.json with scope of top stories, offset of 0, and num30. And this is making it so that the browser executes that fetch right away, starting here, so that when my JavaScript finally runs after cc.js is done, the network resource is already there. So it says, hey, I need to fetch this thing. And the browser says, oh, cool, I already have it. Here it is. So we don't have to wait for that 2-second request in serial, because now it's parallel. So just to give you a look at what this fix and commit actually looks like, this is all we had to do. For our router, in this case, I added some additional headers and I pushed the headers to my response, and that's it. So looking at before and after, before it was taking our page roughly 7 seconds to load, whereas now we are loading in 4.3 seconds. So we shaved 2 seconds off of our request by diving into our network critical path to understand what was causing the page not to load as fast as we wanted. So what did we learn in this example? The first is be aware of your JS-bound network requests. If you're executing fetches from JavaScript that are always the same, you could think that if you make a Twitter clone or a Facebook clone, you're always going to call feed.json. Why do you have to wait for the JavaScript to load before you call feed.json? Call it up front. Second is it's very helpful to utilize the network waterfall and screenshots in tandem to see your load time as your users actually experience it. The third, I recommend that you use network simulation to experience your site on different speed connections. I think most of us are very spoiled on our development machines. We're using a higher end machine. We're not developing on our phones. We have a high throughput network with low latency, but the reality is our users are not on those networks and don't have the same computers that we have. So it's very helpful to simulate their experience so that what you build can better serve them. Additionally, I have pushed a few resources down here for you. The first is how to do adaptive serving based on network quality. And the additional one is some more background on how to preload content in the browser using Linkrel Preload. So if you're curious about these things, these techniques, check out these 2 URLs. Okay, cool. No questions anywhere. Wonderful. So for our next section, I want to talk about another application that I wrote, probably the most important application that I've ever written. I'm just kidding. It is an application to draw with emojis. Because why draw with regular things when you can draw with turtles and poo emojis? All right, so it seems simple enough. And I want to explore specifically performance bottleneck. So it's hard to really feel this. It's hard to show you this, but when you're interacting with this site, sometimes it just seems a little slow when you're drawing. The browser doesn't quite react as fast as I want. And the question I have is why? Why is it slow? So to understand what's going on here, we're going to use some new techniques. Again, we will go to the performance tab. We're going to change things though. For our CPU, we are going to do a 6x slowdown. This is much like network emulation, except for your CPU. It's going to make the computer act slower. Now this case is a little bit easier for us because we don't have to reload the page. We don't have to test this. This is going to be interaction performance profiling. So to do this, instead of hitting the reload page, we are going to hit the record button. So we will start the recording. Now you, oh, yes, DevTools crashed. All right, it was bound to happen. Let's start over. I feel like it's not a good demo unless DevTools crashes. All right, let's start this again. So we will record and we will draw with the turtles. Oh, don't crash. Okay, good. Okay, I'm not going to attempt it to crash again. So we have our profile. We can see screenshots, us drawing with the turtles. Good, good, good. But what I'm interested here is less on the network requests, not on the screenshots, but this, the butterbar area. So we can see in this top area that something's eating up a ton of our resources and that we're barely hanging to 60 FPS. So this top area here is pretty confusing. Let me explain what's happening. So this is showing us how many frames per second we're shipping. This is the FPS chart. It's right on top of the CPU chart. Normally, if we're at 60 FPS, this should be solid green and stacked up. But as you can see, we dip down, we dip, we don't ship any frames, and it's not quite at 60 FPS. Diving into our main thread area and our interactions input area, we can see as we're dragging, this is us, the mouse moving, we can see in the main thread that we're doing quite a bit of work. When we zoom in further, we can see that these are highlighted in red. When it's highlighted in red, it means that it has a significant amount of delay going on. Looking again at the summary panel on the bottom, we can see that this mouse move interaction was waiting for the main thread for 30 milliseconds. So if our goal is to ship a 60 FPS experience, that means that we only have 16 milliseconds. So we were 2 times our budget here when we were moving the mouse. So the question that I have is, what's going on? What is eating up all of this time? I know some of you may be thinking 60 FPS was so 2010. My phone has 120 FPS screen, and that's true. So for modern iPads, for modern displays, many are much faster than 60 FPS. So your budget goes from 16 milliseconds down to 9 milliseconds, down to 6 milliseconds. So you can tell like the simple interaction of drawing turtles on the screen is way over budget for any device, whether it's 2010 or 2020. So let's dive into this to understand what exactly is eating up our time. To do this, we are going to specifically look at the main thread input here. And what I'd like to do is I like to zoom in using my mouse wheel to a very specific area and hold Shift and drag. When I drag here, it's going to select a period of time, and anything that I do in this bottom panel will be a summary of this range right here. So if I click bottom up, I now see everything that is eating all my time, that is consuming the resources on my machine. Personally, I like to sort by self-time in descending. So this is going to tell us which functions were the most expensive based on their self-time. So I see a function call, not very helpful, but I can dive in more and I can see that a function call that's triggered from a load event is actually eating up 39.2% of this 147.3 millisecond range. So we saw that we were almost 2x over our budget, so that we can see that this is accounting for a significant portion of that over budget percent. This is 40%. So if we could fix that, we would then be able to ship a 60 FPS experience. So it's unclear. When I look at this, it is unclear what exactly this load is and why it is taking so much time. So for me to understand what's going on, I have to look at the code. So I see in the stack here, I see that when the mouse moves, we call a function. When we call a function, we call this onMouseMove, which then calls paint at point. And this is where our work seems to be happening right here. There's our friendly function call. There's our mouse move. Okay. But then it seems like we're kicking off some work here and then we're waiting a little bit, and then our load call kicks in. So this load call happens, and when we click load, we then see this additional function, draw image. Ah, okay, so this is now making a little bit more sense. Emoji image.onload is triggered when the image loads. And then if I had to guess, yes, here it is. We are then drawing an image. So that makes sense. When I draw with emojis, it has to load the emoji image and then paint it. But the question arises for me, again, why do we have to load an image when we've already drawn that image? I understand if I'm changing emoji, like it has to load that, sure. But why does it have to keep loading that over and over again? And so offline, I pulled on that thread quite a bit. And I realized that, well, you know, if we cache those images, we can probably see a significant savings. So that's what I did. We'll look at the commit first. So what I changed here was I made it so when we loaded an image, I would set in our image cache, which is a map here, the image that we loaded. So we were using a caching approach. And then whenever we call get image, I first check to see if my cache has that image. If the cache has that image, I then resolve my promise with the image. There's no need to load that image again if we already have it. So essentially we're just caching. We're not redoing work that we were doing. Before, the implementation was this, always. We would create a new image, we would set the path, and then we would trigger a callback when that image was loaded, even though we had already loaded that image. The initial implementation, I assumed, well, the browser has that cached. How expensive could it really be? Well, let's find out what sort of difference that made. We will load up our performance profile again. Our CPU will go 6x slowdown. We will record. Let's say, oh, yes. Again. We'll try again. All right. All right, there we go, 6x slowdown, wonderful. All right, so pretty different. We can now see in the top area that we are hovering much closer to 60 FPS. I'm just double checking that we're at the right URL we are. Okay, cool. And then if we select an area and go into bottom up, we can see that it has a very, very different performance characteristic here. Sure, function call is still there. Sure, mouse move is still there. But you know what we don't see anymore? Load. We don't see that image load. So what we can see here is our frames now, as we're interacting, are only taking 12.6 milliseconds. So we are shipping above 60 FPS. We're shipping at 79 FPS, whereas previously we were shipping, let's see here. It's not going to tell us. There we go. Previously, we were shipping closer to 26 FPS. So just by being lazy and caching and reusing our code, we were able to make a big difference. All right. So we were able to completely change it. This is a before and after. We were able to go from a very expensive operation, and you can see it here. This butter bar area below the FPS meter, you can see how tall this area was and how much work we were doing. Afterwards, we are able to shift it so we do much less work as we're interacting in this critical interaction to make the experience much better. So what did this example kind of show us? The first, for me, most important is we shouldn't assume where our performance bottleneck is. I always, when I build something, I never think that it's going to be slow in something like this, where I'm drawing an image. But of course, that's what always gets me. I always think, oh, this nested for loop, or oh, this complex algorithm is where my expense is. But normally, that's not the case. Normally, the performance bottleneck happens to sit always on these critical interactions that your users are doing over and over again. And that's why performance profiling your interactions is just as important as performance profiling your load time, and sometimes more important. So always profile your key interactions. Every application has one. If you're building a form, typing in that form is pretty important. So you should profile that. I've interacted with many forms where people have an on key down event listener, and then they kick off all this work. And so when I'm actually typing, it's very slow. So that's why it's super important to profile your interactions on your page. The third thing, and this is what really helps me, is it's important to establish a baseline before you make additional changes. Sometimes we say, oh, this app is slow. I'm going to go in and change all this code and have this huge commit that has 3,000 lines of code. And it's better. It's better because I think it's better. If you don't have the baseline, there's no way for you to compare the before and after. Even though establishing a baseline may take quite a bit of work, it pays off because you're able to do this heads up comparison where you can say, before it looked like this, now it looks like this. It's much more objective to say, this is much better. Here's the evidence, here's the proof, and here's the minimum set of code that we have to change to unlock this, versus going in blind to a large code base, making changes and just assuming because you followed some advice on the internet that it's better. So always profile, measure, fix, and then remeasure. I put some additional resources here. The first is a guide from the DevTools team on how to evaluate your performance. The second is a presentation that I actually quite like, which is just some general tools, tricks for DevTools. All right. So this is interesting. I think everyone always, of course, wants to know more. So there's two resources that I would strongly encourage you to check out. The first is web.dev/fast. And this is a site from the Chrome team that goes into quite a bit of detail about how to make your load time much, much faster. Additionally, there's a whole section here on measuring the performance in the field, which is all about how to instrument your application, how to get telemetry back from your page in the wild so you can actually see how your application is performing. So definitely give this page a look and check it out. The second is my personal favorite, which is the web updates from the Chrome team. And this is where they push everything that's happening in Chrome. As I'm sure you're familiar with, if you've ever opened up DevTools, you see a prompt in the bottom that says, hey, what's new in DevTools? Every single month, it seems. And this is actually a very helpful thing. So Case on the DevTools team puts out an article along with a YouTube video talking about all the new DevTools features that come every single month. So this website has updates going back to 2011 of all the new features. And so the DevTools team, like any product team, is constantly pushing new features and improvements. Many of these improvements can directly make your life a lot easier. So it's worth staying on top of this. And I think that is mostly it. There's a few questions in the chat, so let me just run through those.
Awesome. Thank you so much for that great talk, Sam.
Yeah.
If anyone has questions in YouTube, just put it in the chat and I'll read it out loud. If you're participating in the Zoom and you're camera shy, feel free to type in the chat. I can read that as well. Or hit like the one of the reactions and I'll say your name and we can actually have you ask the question. So one thing I see in the chat is a question from Dave. He's asking, do you have any recommendations about when you would use WebAssembly to improve performance?
Yeah, WebAssembly for performance is not a cure-all. Say if you're doing things like image decoding, if you're doing algorithmically complex things, WebAssembly is awesome. It's great. But for building generic websites, you can't just throw WebAssembly at the problem and assume it's going to be very fast. So the emoji brush example application, nothing in there was algorithmically complex. It was all about loading the image and making the browser do additional work. So WebAssembly doesn't just fix that. You still have to do the work. You still have to interact with the browser. You still have to load resources. But what WebAssembly does enable you to do is things that you couldn't ever do on the web before, such as, do you want to chroma key your video to trim the background out of your video? Do you want to do real-time WebGL animations? Cool. Well, that's all things that you can definitely do in WebAssembly that will make things much faster. But in general, WebAssembly doesn't just fix things.
Awesome. Todd Pear had asked, is it preferable to use the header technique instead of the link tag in your markup?
Yeah, this one's a little bit trickier. So different browser engines work differently. So the thing with shipping it in your HTML is the browser has to download that HTML. So depending on how high up in your document you have that Linkrel Preload tag, you can actually pay a network penalty while those bytes are transferring over the wire. Now, using a header tag has some advantages in that those header tags come down before the content. So you have your headers and your response, and the response can be chunked over many, many, many round trips. So my personal preference is to use the header tags because I know they're going to show up in the browser really fast. But for a lot of us, that is a harder thing to do because we might not have control over our page, or our server admins might not like us pushing arbitrary headers. So my recommendation would be, if you can get away with the headers, do it. If you can't, putting it in your document works almost as well.
Sure. Sergey asked, how is support for mobile browsers for techniques like preload or pre-render? I thought pre-render wasn't always supported.
Yeah, I think Paul dropped some knowledge. So I have not dove deep into pre-render. Preload and pre-connect are very, very well supported. So I would definitely encourage people to use that technique. I can't really speak to pre-render too much.
Dave also asks, is there any simpler tool in Chrome DevTools that you would recommend for less advanced performance optimization?
Yes, great question. So there is an awesome tool built into DevTools called Lighthouse. Let me present real quick. We'll take a look at my own website because we can make fun of that. That's fine. So Chrome has an additional tab, a little buried, called the Audits tab. And the Audits tab has a built-in integration to Lighthouse. And if you haven't heard of Lighthouse, what it is a tool to identify and fix common problems that affect your site's performance, accessibility, and user experience. So perfect for this question. We have a whole bunch of options here. I will just check them all except for progressive web app, because I know my website is not a progressive web app. And let's test it on mobile. So to run this, we can press the generate report button, and Lighthouse will run all of many of the techniques that we just ran through automatically for us. So this is going to do things like load the page on a mobile network with a slowed down CPU. It's going to look at our request waterfall, and it's going to look at all these different things that have been coded into the audit tool and tell us what are the issues and where can we make improvements. Now, the thing to acknowledge is that this is not about your interaction performance profiling. This is specifically about your load performance on mobile and as optionally a progressive web app. So the cool thing and what I love about Lighthouse is it actually gives us a list of opportunities, things that we can do to speed up our application. And each of these things have a learn more. So you can see right here, consider using pre-connect or DNS prefetch. So just what we talked about. Additionally, it calls out some things that are slowing our page down. So definitely, if you feel like what we just ran through is a lot, and I agree, it is a lot, start with Lighthouse. Lighthouse is a really easy way to get started. Additionally, if getting to this point in DevTools is difficult, you can go to web.dev, and web.dev has a test my site button. Test My Site will enable you to actually run Lighthouse in the cloud. So you don't even have to run it locally. You can run it in the cloud, profile your website, and get this Lighthouse report directly in your browser without even having to use DevTools, which is quite nice. So definitely start with Lighthouse, go to web.dev/measure, start there, and then maybe dip your toe into DevTools after you start there. But this is definitely a wonderful place to, begin your path to improving the performance of your site or web application.
Awesome. The Paul Irish asked, how do I analyze the performance of an SPA navigation?
Good question, Paul. So normally for a single page application, understanding the performance as you go through many different pages can be quite challenging because it's not like you're loading a regular page. You're interacting with pages in between other pages. So what I normally recommend is that people go into DevTools and I'll present once more. So I normally would recommend that people go into the Performance tab and click on the Record button here. In the Record button, I would then go through the PWA steps. As you see, we're loading these different pages. And then I will manually stop my profile. So when this loads, you'll see, here we go. So web.dev, according to this, has some opportunity. As you can see, our butter bar is quite full, but our FPS is still quite high. So what I'm looking for here is when we open the menu right here, this is us actually sliding out the menu and then clicking, and we can see the blog loads right after we click here. So it's the same technique as what we did before. I would select this interaction right here. I'd go down here and say, oh, look, here's our run micro tasks. So changing the page in this case is taking 283 milliseconds. And interestingly, the cost here is not on actually updating the page. It's on this update DOM force focus function, which is counter to what I would expect. So it's probably worth the web.dev team diving in here to understand what's going on, and I can follow up with them. But this is how I normally profile PWAs or navigation inside of a PWA, is I will start the recording, I will interact with the page, I'll go in between the different apps, and then look at what is actually happening as I transition between those two pages. So you can see that we've already found something here, which is fascinating.
Awesome. Facundo Gonzalez asks, can HTML imported with React nodes be rendered alongside, rendered via SSR alongside JavaScript to improve speed? It's in the chat if you.
Yeah. Let me think about this question. So yes, the high level question here is yes. If you can server-side render your content, you can increase performance significantly. So the best thing that you can do to the browser to make your page load fast is make the browser do as little work as possible. Running JavaScript to render your page is expensive. So usually if you're using a more modern framework, whether it's Ember, whether it's Next.js, whether it's server-side rendered React, you can do this already. Many of these tools come along with a server-side render component. So by server-side rendering your content, that means that when you load the page, you get a page rendered, and then your JavaScript runs and then hydrates your DOM. You may have seen people referring to this hydration problem. So I would strongly encourage everyone to server-side render if you can, because it does have a non-zero impact to your performance, because essentially you don't have to run any JavaScript to see the content. And if your page is all about content, why require JavaScript to run if you can just render it on the server?
Sounds good. Sergey asks, can I use preload to a URL path versus pre-render? And he has a case where he's detecting the most likely next page that a user is going to go to, akin to guest.js, and wanted to pre-render the next page. So he wants to preload a full web URL.
Yeah. So you could be tricky here. I think I haven't played with this technique too much, but theoretically you could load the page in DOM and actually just swap the DOM nodes. The typical Chrome cache, what will happen is it will cache the bytes over the wire and not cache the rendering work for you. So if you're trying to optimize the bytes rendering or the byte network overhead, I think like guest.js or one of the tools that are mentioned in the chat does, it sort of prefetches it so you don't have to pay the network overhead. But if you wanted to actually prepay the cost of rendering the page, I would say that you would have to render it somewhere in your DOM to make the browser do the work and then sort of swap those nodes. It's a really interesting question. I definitely think worth exploring.
Cool. RTM is asking, getting back to preload, if we inject link preload into shadow DOM, is it the same impact as injecting it to the body instead?
Good question. It should work based on my understanding of the spec. It should work. So if you inject it, I've done this before where I run JavaScript to inject Linkrel Preload, and it has worked in the past, specifically for this problem. So if you have dynamic content that you know you're going to need to load, but you need to run JavaScript to determine the link, I have in the past run JavaScript on the page that's served from the server to run a tiny bit of JavaScript to insert Linkrel Preload tags. And then I download my big JavaScript bundle. And then my big JavaScript bundle calls those resources so that by the time I call for those resources, the Linkrel Preload content that I generated and inserted has already preloaded for me. So I've definitely done that technique before, and I can confirm it does work.
Great. Jorge asks, is it any easier to measure JavaScript performance when you avoid anonymous functions in your code?
So this was, I've seen this mentioned many times. So there's a cost of binding functions in JavaScript. That's sort of just a fixed cost. When you write a function, the browser has to do work to understand the scope and where that function lives and what should be visible to it. For a long time, there was a understanding that avoiding anonymous functions came with performance benefits. The reality that I've seen in modern JavaScript and modern engines is that's no longer true, that the cost is much less than what you would think. And that's the thing about this sort of advice that I read when you say like how to optimize my website for performance. There's a lot of advice that was written in 2012, 2013, 2014, 2015 that just no longer applies because JavaScript engines, V8 in this case in Chrome, are constantly changing. They're constantly optimizing for common use cases. So arrow functions or anonymous functions used to come with a significant cost, whereas now the cost is much, much smaller. So I would say I wouldn't expect avoiding functions. Like if you changed all of your code to avoid functions and only use named functions, that your performance would all of a sudden become much better. But again, that's just my understanding as of today. I would definitely say it's worth measuring and seeing how your app performs.
Raphael asks if you've ever tried to, I think he's asking if you've ever tried to limit the rate at which your application draws, like the frame rate.
I have done this. So a lot of times, now I think the canonical example that I'll always use is window.onScroll. I think many of us have wanted to do something when you scroll on the page before. So the browser has a window.onScroll function. So you say window.onScroll equals function, and then you do your work there. But window.onScroll fires much, much, much higher than 60 FPS. It fires, in some cases, 1,000 times per second. So what I typically do is I throttle those sort of interactions to 60 FPS. Or instead of throttling to 60 FPS, I will throttle using request animation frame. So for those of you that are not familiar, let me share one more time. Okay, so let's go into sources. We will make a new snippet here. Here we go, a new snippet. Again, I'll show you a new DevTools feature. New, it's old, but you may have not seen it before. So snippets, for those of you that don't know, is a way to write JavaScript that you can quickly evaluate. So if I wanted to do something like this, I can now write a function, have a REPL, and sort of go through development. In the past, I think for me personally, I would always write these huge statements in the terminal here. And it would it would be very tedious. I'd have to make sure to do the enters. So snippets allow us to write code quickly right here. So request animation frame is a handy API that will get called at most the frame rate of your display. So as we talked about earlier, every display does not fire at 60 FPS. Some displays fire much higher, some displays fire lower, depending on the network situation or the battery or power supply of the device. So request animation frame paired with a throttle is typically what I do. So the code is usually something like window.onScroll equals throttled scroll, where throttled scroll is a function that looks more or less like this. So if pending raf return, otherwise pending raf equals request animation frame, and then pending raf equals. So what this approach will let you do, go away. What this approach will let you do here is that throttled scroll will only run when we have not already, when work is no longer scheduled. So this will essentially FPS cap your interaction. No promises if this code works. I just wrote it real quick. But I've done this pattern many times, and I can confirm that this does actually save you significantly on your interactions. This is also very helpful for things when the page might already be FPS constrained. So you might already be doing complex animations, and you might not have the budget to run something at 60 FPS. What request animation frame will actually do is it won't run this code until it has time to do this animation. The browser sort of keeps track of how much it's shipped already in the current frame. And it will say, hey, I'm going to defer this work to the next frame when I know I'm going to have time to do this work. So I strongly encourage this approach. Yeah, good question.
Cool. Dave asks, other than Google's documentation and web.dev/fast, is there a course or other material that you'd recommend to become good at Chrome DevTools?
The best advice that I have is be curious and don't stop asking why. So for me personally, the way that I learned about this was I was working on a client project and I was curious why something was slow. And so I went into DevTools, I looked at the internal document or the documentation from the Google team, and I started poking around. And I had many questions, many things weren't clear. And so I engaged with the community that I knew on Twitter, over email, and on GitHub, and started asking questions. So just stay curious, keep asking. Things are more documented now than they've ever been, but I know this isn't easy to get into. I know this isn't easy to start with. But starting somewhere is a great way to grow your expertise and become that go-to person in your office or on your team. When someone says, "Oh, this is slow," let's ask Sally, or let's ask Joe. Just by being curious and just by trying to answer the question, why does this feel slow?
Definitely. Cool.
So to piggyback on that last part, if you're starting like a new project and that you know that it's going to go for like a certain time and it's going to reach certain size, do you have any recommendations on which or at which point you should start measuring and like how often to do it? And like, it's like you don't want to jump too early, right? But like, what could you recommend regarding that?
So for large projects, what a lot of teams will do is they will set performance budgets. I know Facebook does this. I know a few other teams at large companies do this, where they'll say, we know that our current application is, let's say, 250 kilobytes for our JS payload. We're going to add a feature of the new like telephone dialer feature. Okay, we're committed to not growing our final JS bundle size more than 10 kilobytes with this feature. So they sort of set a goal, and then if their feature comes over size or over budget, they'll start trimming it away or keep working on it before they deliver it. So I know that's kind of an extreme example, and a lot of us aren't fortunate enough to have that kind of resourcing to build out the instrumentation and the budget approach. But for long-running projects, I do think it's valuable to at least set a baseline of where you started before you built the feature and then after you built the feature. Because a lot of times we build this feature incrementally and then all of a sudden our site's slow and we don't know why. But it turns out that it was the one commit that we made a month and a half ago on this 3-month-long branch that actually slowed us down. And without that baseline, it's very hard to understand.
We got another question from Artyom. It's a long one, but I'll try to read it. If you need to wait for a node to be shown on a page for about 5 seconds, or waiting some other interaction, for example, scroll, click, anything like that, and then you mutate the DOM node or change it in some way, and then you want to give up if the node hasn't been shown, when would you use request animation frame in a loop to wait for the next free frame? Is in general a good idea to do that?
Yeah, so request animation frame has a funny API quirk where I think if the browser never has a spare frame, it will never actually call the callback. We can confirm that real quick. It's either that or request idle callback. So calling request animation frame in a loop is actually not free. I'll have to check later if it's request idle callback or request animation frame. Paul might know. But essentially, if you want to wait to see if a frame has been dispatched recently, I would recommend request animation frame. You only need to call it once though, unless you want to see if many frames have been shipped. If you want to see if many frames have been shipped, what you should do is call request animation frame, then schedule another request animation frame inside of that request animation frame to sort of do the wait for n number of frames to be shipped. But that would be my recommendation, is to go with that. But you don't need to call it in a loop, because if you call request animation frame in a loop, what will actually happen is request animation frame will get scheduled. Many of those callbacks will get scheduled in the exact same frame. So it's less obvious what that does. Paul clarified, it's request idle callback. It doesn't always call everything. You have to set a deadline with request idle callback. Animation frame will eventually get called. Thanks, Paul, for the clarification.
Anybody else have a final question? I think that might be it.
Going once. All right, if we don't have any more questions, then thank you again, Sam, for this amazing presentation. pretty sure that I'm not the only one that learned a lot watching this. So thank you for your time and for answering all the questions from everyone that was attending. Thank you for being with us today and sharing your knowledge with our community. And thank you for everyone that attended as well and for all of your amazing questions. We really hope you enjoyed this, and I don't know, I think we'll wrap it up then. Everybody stay safe, watch your hands, and we'll see you next time. All right. Thanks, everybody.
Thanks, everyone.
Thank you.